Okay, good morning. Hope everyone's doing well today. So today we're going to do an exercise based on the assignment we did last time on Tuesday. So Tuesday we did example 4.5, which is due next Tuesday. And so the assignment or the exercise for today is a little bit different because we're going to do just some practice problems. Well, I mean it's an assignment you have to do, and so I prepared this exercise because it'll help you for one of the exam questions. Okay, so the drug production assignment is based on the example 4.5 model, and let's go ahead and go to that. So after example 4.5, you'll see assignment drug production. You can go there and open up the assignment. Okay, let's open this up. All right, so this is similar to the one we did, the practice problem for example 4.5. And so the assignment here is 5 questions. Okay, so there's no Excel file that goes for this assignment. It's just you have to finish the assignment. And this one is going to be due next Tuesday as well. And so normally this is like if we had an in-class class, this would be a group assignment, but unfortunately we can't do that, so it's going to be kind of individual assignments. And so what we'll do is I'll do one as an example. I'll do as many as you guys want me to do as an example, and then once you feel comfortable doing the rest of them, then you can finish the rest of the assignment. But we can do as many as until everyone understands the concept. So let's just start doing. We'll do definitely number 1 in class. So let's do number 1. And just I want you guys to get the idea of this type of question, because there will be one on the take-home midterm 2. Okay, so you see a screen cap of something similar that we did with the drug production one, example 4.5 from Tuesday. So remember we had three different types of drugs, and the drugs sell for different prices, and different amounts of like the cheaper drug go in to make the more expensive drug, which you can sell at the market price. So in all these you'll see that I've changed the labor hours and the drugs that go into the other drugs, and also the selling prices. So all the things we're going to be looking at are here in this top blue area, and then also what drug is being sold. And remember, we tried to explain this concept with the solver table and with the practice problem, but I think we'll get it for sure once we do a bunch of examples. So let's just start doing this. So this is the exercise for today. All right, and I'll have you guys try to answer some of the questions so I make sure that we understand it. So part A, for number 1. Okay, so assuming no changes, which drug is sold exclusively? All right, so the first thing you have to do is just look at this screen cap and determine or just report which of the drugs is being sold. All right, so right now, if you look at the screen cap, what's the only drug being sold? So can anyone say which drug is being sold?
Drug C.
Drug C, exactly, yeah. So if you look at the units sold row, you see that there's no drug A, no drug B, but we're selling only drug C. So exactly. So the first thing note is it's drug C. Okay, so drug. All right, and then what explains these results? And remember, we had a concept that we learned last time that explained why one drug is being sold as opposed to the others, and there's only one input to the production process, right? And so therefore, whichever drug is going to give you the highest return in terms of the labor it takes to make it is the one that's going to be sold, which in this case is drug C. So that concept was revenue per labor hour. So, revenue per labor hour is always going to explain the results. So, what we want to do first, before we can go to part B, is determine the revenue per labor hour for drug C, because right now that's the one that's being sold as opposed to the other. So let's calculate. So let me give you the general form again for revenue per labor hour. Okay, so this is essentially the same thing we did in the exercise after example 4.5. So revenue per labor hour in this context is just the drug selling price, and then the labor hours required to make that drug. Okay, the total labor hours, right, including if there were labor hours that went into the drug ingredient, that has to count too. So let's see if we can figure out the revenue per labor hour for drug C. Alright, so you'll see that first just put in the selling price. This is the easy part. So you see the selling prices are drug A, market price is 900, for drug B it's 1,000, and drug C is 3,000. So right now the drug selling price for drug C, the one we're concerned about, is 3,000. So let's just put that in. Alright, so now this one, they get harder as we go along, but this one is fairly easy. So can someone figure out the total labor hours required to make drug C based on the structure of the inputs here?
Two.
How many?
Two.
Close.
One, sorry.
Other way.
Three.
Yeah, 3. Okay, so so 3. And so what you want to do is start with the least expensive drug, which is always going to be drug A, and start counting up. So look at drug A. Drug A takes 1 hour to make, okay? Then drug B takes 1 drug A and 1 drug B. So that's 1 hour for the drug A, and then 1 more hour to make it drug B. So for drug B, it's 2. And then drug C takes 1 drug B and then 1 more hour. So we know that this drug B took 2 hours, and then an additional hour to turn it into drug C is 3. So 1 plus 1 is 2, and then 2 plus 1 is 3. So hopefully we see that, because it gets a little more complicated if you add more ingredients and hours. But start from the drug A and then count up the drug B. So do we see how we get the 3 hours here for drug C? Okay, so now, so $3,000 divided by 3 hours gives us exactly $1,000 per hour, or $1,000 per labor hour. So that's what we're trying to match now for the other drugs. But first, let's note that the goal is what drug C is currently doing, which is okay, so drug C's revenue per labor hour is $1,000 per hour. So $1,000 divided by 3 hours gives you, if you do like just divide by 3, $1,000 per hour return. Okay, so that's the level at which we're going to need to answer the other questions for the other drugs for Part B and C. Okay, Part B. A's price needs to be greater than or equal to what for only A to be sold. So what we have to do for the other parts of these questions is determine what the market price would have to rise to for it to be equal to on a revenue per labor hour basis. So what does A's price have to be equivalent to giving us $1,000 per labor hour? All right, so let's start with the general formula and then work back. All right, so the general formula is revenue per labor hour is the drug selling price divided by the labor hours required. So let's determine that for drug A. All right, so you'll see the drug A is selling for a price of $900. All right, and the labor hours it takes to make drug A is just 1, right? There's nothing else going on except there's 1 hour, so it's just 1 hour. So therefore, currently, you can see just divide 900 by 1. Drug A is only giving us $900 per hour, which is less than what drug C is getting. So we can see that is insufficient, but what we have to determine is what the price has to rise to for drug A to be comparable with drug C. So what does the price have to be equal to give us $1,000 per labor hour? So let's put that in. Okay, so what drug A price divided by 1 hour gives us $1,000 per hour. So this one's pretty easy, but what divided by 1 is 1,000? 1,000, right? So you can see that the drug A price of 1,000 is what drug A's price needs to rise to for it to be exactly equal to $1,000 per hour. So the answer to part B is okay, so drug A's price needs to be greater than or equal to 1,000. If that was the case, then both drug A and drug C would be giving us $1,000 per hour in terms of revenue per labor hour. Now let's do the same analysis for drug D. So B's price needs to be greater than or equal to what for only B to be sold. All right. So let's start with what we're currently getting, and then figure out what the correct price would have to be. Okay, so for drug B, the revenue per labor hour currently is the selling price right here, which is 1,000. All right, that's given. Okay, and how many hours does it take to make drug B? Okay, so that's the question for you guys. So how many total hours does it take to make one drug B?
2?
2, yeah, exactly. So you got the one drug A, which takes an hour to make a drug A, and then one more hour to make drug B. So 1 plus 1 is 2. Right. All right. So 1,000 divided by 2 is $500 per hour, right? Which is less than what we're trying to get. Okay. So now let's find out what drug B price needs to go to be equal to $1,000 per hour. So we're trying to find the drug B price increase amount. That is equal to the return of $1,000 per hour. All right, so you can basically just what divided by 2 is 1,000, or you can do 2 times. So what divided by 2 would give us 1,000? That's the question, and that's the answer for drug B. So what does drug B's price have to be to give us $1,000 per hour?
2,000.
2,000, yes. Okay, so the answer for part C is to state that drug B's price needs to be greater than or equal to 2,000 for it to be sold. Okay, so that's how you do these problems, and we'll see some more examples. And so there's on the assignment there's there's 5 total. We've done 1. So make sure you've got this one down, and we can do some more. And you're gonna have to do at least a few by yourself, but we can do as many as you guys want. So let's do number 2. It's the same idea, but I made the latter ones a little more difficult, just given more hours and the prices. So let's do number 2. Same idea, but different problem. All right. So everybody, any questions on what we did? Everybody, yeah?
All 5 columns are like this?
Yes.
Okay.
Yeah. All right. Number 2. All right, so we got the similar screen cap, but there's different labor hours, different prices, and so on. So part A. Okay, assuming no changes, which drug is sold exclusively, and what explains these results is not always going to be the same answer, but again, if you look at the units sold, no drug A's, no drug B's, we're selling 667 drug C, so the answer here is drug C. Okay, so drug C is the one being sold, and revenue per labor hour explains these results. Now the next thing we have to do is figure out what exactly the revenue per labor hour is for drug C. Okay, so the selling price for drug C in this example is $6,000. Alright, so this one's a little more accounting, but can someone try to figure out how many hours it takes to make one drug C by looking at the table here?
Six?
Six, yeah, exactly. So, the thing you should check for, I mean, you should be able to do it, but I try to make them all come out pretty evenly. And so if you get something that's like, a fraction, it's probably wrong. But yeah, it's six, because let's start with drug A. So it takes 2 hours to make one drug A. Okay, so we got that. So that's two. And then, it takes one drug A, right, as an ingredient for drug B. So this drug A took 2 hours. And then 2 more hours, right? 2 plus 2 is 4. And then drug C took one drug B. That drug B took 4 hours, and then 2 more hours to make a drug C, so 4 plus 2 is 6. Alright, so you don't always just add them straight up, but make sure you know, like, start from drug A, go to drug B, go to drug C, and if you count for everything, you should get it. So 2, and then 2 plus 2 is 4. And then 4 plus 2 is 6. So, yeah, that's correct. It's 6 hours. Alright. Yeah, Kayla got it too. I don't know if we got a verse. So, the revenue per labor hour again is $1,000 per hour. Alright, so that's what we need to use as a reference for the other data again. So, part B, A is price. It's not always going to be that drug C is the first one, and then you got to figure out A and B. Sometimes you can just figure out drug C and drug B, but it just turns out the first two, I picked drug C first, or drug C is first. Alright. Okay, so let's figure out the revenue per labor hour for drug A. So A's price needs to be greater than or equal to what for only A to be sold? Alright, so let's start with what it currently is getting, and prove that that is not the right amount, and then figure out the increase in price to be relevant, or to be comparable. Alright, so let's do it for drug A. Drug A's selling price is now 1,000, right? Okay, we already figured out that it takes 2 hours to make one drug A. And that, without any changes, is going to give us $500 per hour for drug A, which is clearly not as profitable as drug C. Okay. So let's figure out the price it needs to go to be equal to $1,000 per hour. Okay, so what does drug A's price have to be to give us $1,000 per hour? So what is the drug A's price got to be here? Yeah. 2,000 is the correct answer that we got in the chat. Yeah, 2,000. Okay, so we figured out what the price has to rise to for it to be comparable. So the answer for part B. Alright, so drug A's conditions to be greater than or equal to 2,000. Okay, let's do it again for drug B. Okay, B's price needs to be greater than or equal to what for only B to be sold. So first let's start with the default or the original status quo labor hours revenue per labor hour for drug B. Alright, drug B is being sold for 3,000. And we already figured out here that drug B, so it takes one drug A and then 2 more hours. So 2 hours for the drug A plus 2 is a total of 4 hours for each drug B. So 4 hours here. And that gives us something not even, which is less than 1,000. What's 3,000 divided by 4? I don't even know.
750.
750, thank you. Okay, 750 is not $1,000 per hour. Okay, but let's figure out what the price has to rise to. We'll probably see where this is going, but
4,000?
yes, that's correct. Yeah, so 4,000 divided by 4 gives us exactly 1,000. Right. Alright, we're trying to find that. We already found it, but... Okay, so yeah, exactly. 4,000 divided by 4 gives us the same return of $1,000 per hour. So, alright, so the answer for part C is drug B's price needs to be greater than or equal to 4,000. Okay, so I think we're getting the idea here. So they get a little more complicated, and I think we're getting the idea, but I do a bunch of these examples, and I still see students get some weird answers on the exam, so I want to make sure that we understand it. But all right, should we do? Yeah, we can do that. All right, so this assignment is all we have planned for today. So let's do another one. Sure, as well. Okay. So let's number 3. Same thing, different numbers. All right. So this one's a little more. All right. There's more numbers to add up. So part A. Assuming no changes, which drug is sold. So if you look at the screen cap, you'll see this time unit sold 0 drug C, 0 drug B. This time drug A is the one that's being sold. All right. So we have to start with drug A. So drug A is the answer for part A. And again, the revenue per labor hour must explain the results here. Okay, we know next step is to figure out what is the revenue per labor hour for each drug A we sell. So let's do that. Okay, the drug A price is right here, $2. All right, and how many hours does it take to make one drug A? All right, so look at the chart and how many hours to make drug A? Two. Yeah, 2 hours. Okay, so the 2 hours. All right, and that gives us a nice even $1 per hour for drug A. Okay, so we need to use that as a benchmark when we do parts B and part C for drug B and drug C. Drug B price needs to be greater than or equal to what for only B to be sold. All right, so let's first figure out again what the current revenue per labor hour is for drug B. Just to confirm, it's got to be less than $1. Okay, drug B is selling for $8. All right, now what I want someone to try to figure out is how many hours does it take to make one drug B given the chart? So look at the ingredients and then look at the additional labor hours. So how many hours does it take to make one drug B? 10 is close because, so the thing is you need, 2 drug A's, and each drug A takes 2 hours, right? So, yeah, 12, right? So so you don't always just add these up, but that was, yeah, see? If you look at it this way, it makes more sense. So each of these is 2. So 2 plus 2 is 4, plus 8 is 12. So yeah, someone Dominic got 12. So yeah, it's, 2 drug A's. Each drug A takes 2 hours, so that's 4 plus 8 is 12. Yeah. Okay, and that gives us, let's see, what was this, 2/3 of a dollar? Or like 50, yeah, it's like 56 cents for something. Alright, so either way, it's less than $1. We gotta figure out what it has to rise to be equal to the dollar per hour. Okay, so
Sorry.
yeah, go ahead.
So when we're doing these tables, like for the labor hours, so like for the next question, drug C, right? So it's 3 of drug A, so it would be 2 times 3, or it would be 2 plus 3.
Yeah, okay, let's get to that one real quick. Let's figure out this one first, and we'll do that. So drug B, so what does the drug B price have to be?
12.
12, yeah. Yeah, so the answer to part B is drug B's price is greater than or equal to 12. Alright, so now let's see if we can figure out drug C, which is probably a little more complicated, but let's start with the current revenue to labor hours, yeah? So first of all, the price of drug C is $11 right now, yeah? Okay, and your question was how many hours does it take to make drug C? So what do you think it is?
Well, like for like not for just this specific question, just in general, like when we're adding, or like just finding out the prices.
Yep.
So like for drug C, it'd be 2 times 3, which is 6, and 1 times 8, which is 8. Or what would it be?
Yeah, so that's right, and then add everything else together. That's exactly right. So,
6, 8,
yeah, so for drug A, you get
14, right? 14 plus 2 is 16.
Yeah, I think that's right. I think it's 16. Yeah, so it's got, so drug A is, so you use 3 drug A's, each of them takes 2 hours, so that's 3 times 6. So 6 here, and then you got 1 drug B, and drug B took 12 hours, alright, so that's 12 plus 6.
Oh, so we don't even use the ones on the table, we use the previous calculated ones.
Well, you have to determine, like, how much does it take to make this 1 drug B from the previous table, alright, so that's 12. And then how much does it take to make 3 drug A's? So that's 3 times 2, which is 6. So 12 plus 6 plus 2 is what?
12 plus 6 is 18, plus 2 is 20.
Yeah, 20. So you see how we get 20? By doing the, like, adding up the previous. So you basically got to multiply the ingredient by the hours it took to make it from the previous column. So it's 1 times 2 plus, 1 times 12 plus 3 times 2 plus 2, which I believe is 20. Yeah, I think this one is 20.
Okay.
Okay.
Gotcha.
Yeah.
It's a little confusing, but
I know, that's why it's fun. Yeah.
I have a question.
Yes.
Aren't you doubling the hours if you're saying it's 1 times 12 instead of 2 times 3 plus 8 times 1?
Let's summarize this.
Because then you're doing the labor hours for eggs twice, aren't you?
Well, no, because it takes 2 hours to make drug A. Right, and you do 3
Yeah,
of them.
so if I have 3 drug eggs, then it would take 6 hours.
Yeah, so 2 plus 2 plus 2. Yeah, exactly. 6.
And then just 1 is 8, or would I say 12?
Well, it takes 1 drug B, and drug B number takes 12. So then you should add the 12 to make the drug B.
Okay.
Okay, so if we do it like this. Okay, so let's just start. We need 1 drug B. We need 3 A's. And then once you have those ingredients, you always need to add the 2 more hours to make it into drug C. Okay? Okay, so the 1 drug B, we already determined the hours, right? It was 12. Okay, and then each drug A takes 2 hours, right? And then plus 2 more hours. Okay, so that's how you gotta do it. You have to figure out how much you need of each, and then the hours it took to make that, and then the extra hours to make it drug C. So now we got okay, so 12 plus 6 is 18 plus 2 is a total of 20 hours. Okay, do we see that calculation there?
I see it. No, it's just, I was a little confused, like navigating the table, but like you put it in a literal, yeah.
Yeah, I know. You can, so if you want to, if it's easier for you to kind of write it out like this, then I'd recommend doing that just to make sure you don't, you account for everything. But, yeah, so sometimes, yeah, it's when you get, and I know the next couple ones, there's more hours, so you have to make sure you account for them. But yeah, kind of figure out how much you need of each, and then just multiply it by the hours it takes to make one of those, and then so it's not always just adding up, it's 1 times 12 plus 3 times 2 plus 2. Alright, so then, what do we got here? So it took 20 hours to make a drug C. Alright, so I don't even know what's 11 divided by 20? Like,
55.
55?
Yeah.
Okay, 55 cents. Alright, so that's not $1. Now let's figure out, which we probably did, what drug C's price has to be equal to $1 per hour. So, okay, so what does drug C's price have to be here to be equal, to give us $1 per hour and revenue per labor hour? So what does drug C's price need to be? Okay, anyone know what drug C's price has to be to give us, 20, right, exactly. Okay, so the answer that we're trying to get is drug C's price needs to be greater than or equal to 20 for only C to be sold. Okay. Alright, so again, a little more, it can get a little more complicated, but it's the same idea. And it's important because if you only have one input to your production process, then it clearly explains how you get the results. Okay. Alright, so we've done 3 of the 4, and so make sure you get this, because I'm not going to post the solutions until after the due date. So this is actual assignment. So okay, so we've done 3 of the 5. We can do one more together class, or you can do them. I mean, if everyone's got it. Yeah, this is all right. I'll post this on YouTube. Yeah, this is being recorded. So, do you want to do one more in class right now? Yeah. Okay. All right. So that's okay. So I just need one yes. All right. So we'll do one more, and then you can do at least the last one, number 5, to finish up the assignment. So we'll do some more. Yeah. Yeah. I'll post this on YouTube. So I guess you can see it later. Yeah. Number 4. Okay. Same idea. All right. Let's look at this one. Okay, assuming no changes, which drug is sold exclusively? Again, this one, all you gotta do is look up and you see no drug C's, no drug B's, but drug A is being sold. And hopefully I got one that's, yeah, so the one you'll do, the last one is drug B. So same thing, but, this one is drug A, right? Yeah. Alright, so drug A is the one being sold. We know that revenue per labor hour always explains the results. Let's go ahead and figure out the revenue per labor hour for drug A? Yep. Drug A is being sold for $30. And how many hours does it take to make one drug A? So how many hours to make a drug A here? Drug A should be the easy one, but how many hours to make a drug A? 3? Yep. Got it. Yep. Alright, that gives us a nice even $10 per hour in terms of revenue per labor hour for drug A. Alright, let's do part B. So B's price needs to be greater than or equal to what for only B to be sold. So let's first figure out the current revenue per labor hour that's going to be less than 10 and figure out what the price needs to get to for it to be 10. Okay? Alright, so drug B's price is selling at 50. Alright, and now let's figure out how many hours it takes to make one drug B. So how many hours does it take to make one drug B? Yeah. So 3 drug A's, they each take 3 or one drug A, they each take 3 hours. So 3 plus 3 is 6. Alright, and that's going to give us something less than 10. Does anyone know what 50 divided by 6 is?
8.33.
Clearly that's not comparable, so let's figure out, well, I don't know what it's going to be, but
60?
yeah, 60, right? Exactly. 60 divided by 6 gives us the same return of $10 per hour. Yep, so exactly 60 here. Alright, so the answer here is B's price needs to be greater than or equal to 60. Alright, so now about C's price. C's price needs to be greater than or equal to what for only C to be sold. And first, let's start with the original revenue per labor hour for drug C. Okay, so drug C is being sold at $100 exactly. Okay, now let's see if someone can figure out how many total hours it takes to make one drug C. So how many hours to make one drug C?
150.
150?
No, well, it's 15. Sorry, my bad.
15? Let's see.
Did I do it right?
So I don't think that's right because it. So let's see.
3 times 3 is 9. 1 times 3 is 3.
Yeah, so it's not 15, but you're close.
Oh.
Yeah. Okay, someone got it. Yeah, 18. All right, so I'll do the steps again to verify it's 18. All right, let's do it like this. All right, so if doing the total helps. Question?
No, I'm just,
Oh, all right. Okay, so let's start with the one drug B, the 1B. And then we need 3 drug A's. And I need an additional 3 hours, yeah? So the 1B takes 6 hours, right? Okay, each A takes 3 hours.
oh, I see where I missed.
Yeah, and then, it's hard to do in your head, Kenneth. So, and then the 3 more hours to make it drug C.
Yeah. I forgot that you have to use the calculated B or like
Yeah, I know.
after calculation.
Yeah, so you have to count for each choice. So now it's 6 plus 9 plus 3. And that gives us 16, but yeah, 18. Yeah, so if it helps to do it like this, which it can't hurt, especially if it's like a complicated C. Like obviously if you have like one of the other ones up here, if you're doing just 1 plus 1 plus 1, then you don't need to do it. But if this helps, I'd recommend doing it because showing your work is going to help. And yeah, it'll. And again, it's going to come out. The answers should come out evenly. So if you get something that's going to be like $1.50, it's probably going to be wrong. Okay, so we know that it takes, revenue per labor hour, so drug C is being sold at 100, we figured out now that it takes 18 hours. Okay, what is 100 divided by 18? Can someone figure that out? It's something less than 10, that's all I can tell you. 5.55? Alright, sounds good to me. $5.56, alright, close enough. Okay, now let's finish the problem here. So we need to see what the price has to rise to be equal to $10 per hour. Okay. Alright, so what does drug C's price have to be equal to give us $10 per hour? Yeah, 180. So 180 divided by 18 is exactly 10. Okay, so the answer here is the drug drug C price needs to be greater than or equal to 180. Okay, so I'll leave the next one for you to do this one. So everyone, any questions on how to do this? Or I think the hardest thing is just counting for the hours. So, all right. So everyone understand the concept to do this one?
Yes.
All right. So yeah, just finish. So this one, agree. All right. So I think it's kind of fun to figure these out, and so you'll be number 5. So you got to turn in the whole assignment. So just post your let's go back. All right. So just to summarize before what time is it? Okay, we'll finish a little bit early. And all right. So example 4-5 deleted on Tuesday is due next Tuesday. All right. So make sure you get that in, and the video's up for that one if you need to catch up on that one. I'll post the video for this one later this morning, and this one's also due next Tuesday, October 13th. So here's the one for today. So just you don't need to post any Excel. Oh, someone's already done it. So just post your either a Word document or a PDF of the answers to the 5 questions. All right, and we already did 4 of them. So just finish up with this one. So turn all 5 in. Okay. And if you have any questions on how to do these problems, let me know because we'll have another one on the take-home midterm. All right, so I think that's it for today. And make sure you get those 2 assignments in by next Tuesday. And everyone have a good weekend. I'll try to get your grades for the midterms done by Saturday or Sunday, sometime before next week or this weekend. Look for those. And so I think that's it. So stay safe and have a good weekend.